All right, buckle up, everybody, because we are about to dive deep into the often mysterious world of research methods in psychology.
Ooh, research methods sounds intense.
Well, it can be, but it's also super fascinating.
Definitely.
And thankfully, we have some awesome material to guide us. Excerpts from Hugh Coolican's book, Research Methods and Statistics in Psychology.
That's a classic.
It really is. It's like the Bible for psych research methods.
So what exactly are we going to unpack today?
We are going to take a look behind the curtain and see how psychologists design their studies, gather data, and try to make sense of the human mind.
I like it.
And by the end of this deep dive, you'll be able to look at a psychology study and understand not just the findings,
But what else?
but also how strong those findings actually are.
Yeah.
You'll be able to spot the good science from the not-so-good science.
It's like having a superpower, being able to decode research.
Exactly. So let's start with the foundation of all science, the scientific method.
Okay, the scientific method, where does that fit into psychology?
Well, that's what makes psychology a true science. It relies on the same empirical methods that drive all the other sciences.
Like physics, chemistry, biology.
Yep, all of them. It's all about observation, data collection, and testing ideas against reality.
Coolican really drives that point home in the book.
He does, but how does that actually work in practice? Like if a psychologist wants to understand, let's say, how memory works, how do they go from a question to a solid answer?
That's where the hypothetico-deductive method comes into play. It's like a roadmap for scientific inquiry.
Okay, I'm intrigued. Break it down for me.
Imagine you notice something interesting, a pattern, maybe a strange behavior, something that sparks your curiosity.
Okay, I'm with you so far.
From that observation, you develop a theory, basically your best guess explanation for what you've observed.
Got it. So that's the theory part. But a theory alone isn't enough, right?
Right. A good theory has to be testable, so you need to create specific predictions that you can actually investigate.
And those predictions are called hypotheses, right?
Exactly. Hypotheses are statements that you can design an experiment around to see if they hold up under scrutiny.
So let's say my theory is that listening to music while studying helps improve memory.
Okay, I like it. A classic study idea.
How would I go from that theory to a testable hypothesis?
Well, your hypothesis could be something like, students who listen to music while studying will perform better on a memory test compared to students who study in silence.
Oh, okay. So you're making it very specific and measurable. Students, music, memory test. I get it.
Exactly. You want to be able to clearly see if your prediction holds true.
So you run your experiment, you collect all your data. Then what? How do you actually know if your findings mean anything?
This is where things get really interesting. We have to talk about the null hypothesis.
Null hypothesis. That sounds ominous.
It's not as scary as it sounds. It's actually a really important concept in research.
Okay, enlighten me.
It might sound counterintuitive, but researchers actually start by assuming their hypothesis is wrong.
Wait, they're trying to prove themselves wrong. Why would they do that?
It's not about proving themselves wrong, per se. It's about being super rigorous with the evidence.
Okay, go on.
So, the null hypothesis is basically saying there's no relationship between the things you're studying.
So, in my music example, the null hypothesis would be that music has no effect on test scores.
Exactly. And then the researchers gather evidence and use statistical tests to see if they can confidently reject that null hypothesis.
So if they find enough evidence to say, nope, music definitely does something, then they can start to support their original hypothesis.
It's like a double negative. You're trying to prove that there is a relationship by disproving that there isn't one.
That's a bit of a mind bender, but I think I'm starting to get it.
It takes some getting used to, but it's a really important part of the scientific process. It's all about minimizing bias and making sure the findings are rock solid.
Right, because one study alone isn't enough to rewrite the textbooks. You want to see those findings replicated.
Exactly. Replication is key. Other researchers should be able to repeat the study and get similar results. That's how you build confidence in the findings.
So this whole process, theory, hypothesis, testing, and replication, it's all about getting as close to the truth as possible, reducing bias every step of the way.
That's the goal, to build a strong case, just like a detective gathering evidence.
Makes sense. Now, here's something I've always wondered. Are experiments the only way psychologists do research? I mean, it seems like the gold standard, controlling all the variables, manipulating the situation.
Well, Coolican actually challenges that assumption. He points out that experiments aren't the only tool in the research toolbox.
Really? So it's not all about lab coats and controlled environments?
Nope. Sometimes you can't or shouldn't manipulate variables in a lab
I
setting.
guess that makes sense. Like, how would you study the psychological effects of a natural disaster?
Exactly, you can't exactly create a hurricane in a lab.
Hmm, true.
Right.
So what do you do in those cases?
You might use a non-experimental method. There's actually a whole variety of them. Coolican talks about observations, surveys, case studies, all sorts of approaches.
So it's like having different tools for different jobs.
Precisely. You choose the right tool based on your research question and the practical and ethical considerations involved.
That makes sense. It's all about being flexible and adaptable.
And speaking of tools, we need to talk about variables and research design, which is like understanding the materials before you start building anything.
Okay, variables, that's one of those words I feel like I kind of know, but maybe not really. Cooligan defines them as anything that can change or be measured. But what does that mean in the context of designing a study?
He makes a really important distinction between independent variables and dependent variables.
Okay, independent versus dependent. Break it down for me.
Think of the independent variable as the thing you're manipulating or changing in your study.
So the potential cause.
Exactly, and the dependent variable is the thing you're measuring to see if it's affected, the potential effect.
So going back to my music and memory example, the type of music, or whether music is played at all, that would be the independent variable.
Yeah.
And the student's test scores would be the dependent variable.
You nailed it. The music is what you're manipulating, and the test scores are what you're measuring to see if the music made a difference.
Okay, I think I'm getting this cause and effect, independent and dependent. It's all connected.
It is, but there's a catch. Researchers have to be incredibly careful to control for those pesky extraneous variables.
Oh, right. Those are the variables that could mess up your results, even if you've got a great design.
Exactly. They're like those little gremlins that can sneak in and influence the outcome when you're not looking.
Okay, can you give me an example? I'm having a hard time picturing those sneaky little gremlins.
Imagine you're studying the effect of a new teaching method on student learning, so that's your main focus, right?
Right.
But what if one group of students is always taught in the morning when they're fresh and alert, and the other group is always taught in the afternoon when they're tired and sluggish?
Ah, I see where you're going with this. The time of day could totally affect their performance, regardless of the teaching method itself.
Exactly. That's an extraneous variable, and if you're not careful, it could make it seem like the new teaching method is more effective than it really is, or maybe even less effective.
Wow. So there are all these hidden factors that researchers have to consider. It's like they're playing detective, trying to rule out all these alternative explanations.
That's a great way to put it, and sometimes those extraneous variables are so sneaky, they're almost impossible to disentangle from the independent variable.
Those are called confounding variables, right?
They're like the masterminds of deception in the research world. They can make it look like there's a relationship when there isn't, or they can mask a real relationship altogether.
Okay, I need an example. My brain is starting to hurt with all this abstract stuff.
All right, picture this. Researchers wanted to see if babies preferred complex patterns over simple ones, so they put a complex pattern on one side of the crib and a simple pattern on the other side.
Seems pretty straightforward. What's the problem?
The problem is, what if babies in that particular crib have a natural tendency to look to the left, maybe because of the way the light is coming in or something?
Oh, I see. Their preference for looking left would make it seem like they prefer the simple pattern, even if they're actually more drawn to the complex one.
Exactly. That's a confounding variable. The baby's inherent preference for looking left is messing up the results, and the researchers might not even realize it.
That's a really good example. It shows how something totally unrelated to the study can throw a wrench into things.
It highlights why researchers have to be incredibly meticulous in their designs, constantly thinking about potential confounding variables and how to minimize their influence.
So even with the best design studies, there's always a chance for things to go wrong.
There is, and Coolican talks about two main types of error: random errors and constant errors.
Okay, random versus constant. What's the difference?
Random errors, as you might guess, are those unpredictable hiccups that can pop up anywhere in the research process. Maybe someone sneezes during a crucial measurement, or a participant misinterprets an instruction.
So those are just random fluky things you can't really control for those, right?
Not really, but the good news is that random errors tend to cancel each other out over a large sample size.
So the more data you have, the less those random errors matter.
Exactly. They kind of average out in the end, but constant errors, those are a bit trickier.
Why are constant errors more problematic?
Because they systematically push the results in a particular direction, they bias the findings, and that can be really hard to detect sometimes.
I see. So it's not just random noise. It's like a systematic distortion of the data.
That's a good way to put it. And Coolican has this great example of a constant error called the investigator loose procedure effect.
Oh, I remember that one. It's about how the researcher's own expectations can influence the results.
Right. He talks about a study where researchers were led to believe that sensory deprivation either caused hallucinations or didn't cause hallucinations.
And then what happened?
Even with pretty vague instructions, the researchers who thought sensory deprivation caused hallucinations were much more likely to find evidence of hallucinations in their interviews.
So they were kind of seeing what they expected to see, even if it wasn't really there.
That's the danger of constant errors. They can be very subtle, but they can have a big impact on the findings.
It's like a self-fulfilling prophecy. If you believe something strongly enough, you might unconsciously find evidence to support it.
That's why blinding is so important in research. Keeping the researchers in the dark about certain aspects of the study can help minimize these kinds of biases.
So it's like a safeguard against our own expectations. I like it.
And speaking of safeguards, we should talk about the different ways researchers structure their studies, their research designs.
Okay, designs. That sounds important. I know Cooligan mentions this idea of a research cycle. What exactly is that?
It's basically the roadmap that researchers follow. It goes from theory to design to data collection to analysis and then back to refining the theory based on the findings.
So it's not a one-and-done kind of thing. It's a continuous process of asking questions, testing ideas, and refining our understanding.
Exactly. It's a cycle, always moving forward, always building on what we've learned before.
I like that. It shows how science is always evolving.
And the type of research design you choose depends on where you are in that cycle. There's a whole spectrum of approaches, each with its own strengths and weaknesses.
Let's start with the classic, experiments. What are the key principles of experimental design according to Coolican?
He emphasizes the importance of control, which is all about minimizing those extraneous variables we talked about.
Right, those sneaky gremlins.
Exactly. In a true experiment, you manipulate the independent variable while keeping everything else constant. It's like creating a mini world where you can isolate the effects of the one thing you're interested in.
So it's about creating a very specific, controlled situation where you can observe cause and effect.
That's the goal. But of course, it's not always possible to control everything perfectly, especially when you're dealing with human behavior.
And that's where those pesky extraneous variables come in.
They do, and that's one of the reasons why Coolican differentiates between lab experiments and field experiments.
Okay, lab versus field. What's the difference?
Lab experiments offer a lot of control. You can really fine-tune the environment and the procedures, but they can also feel artificial.
Right, because people don't usually live in labs.
Exactly. So field experiments take place in real-world settings, which can make the findings more generalizable, but you also lose some of that control.
So it's a trade-off. Control versus realism.
And the best approach depends on the research question.
Makes sense. If you're studying something like reaction time to different colors, a lab setting might be ideal. But if you're studying how people behave in crowds, a field experiment would probably be more realistic.
Exactly. You choose the tool that fits the job.
Now, Coolican also talks about these other types of experiments, quasi-experiments and natural experiments, where you don't have as much control over assigning participants to conditions.
Right. Quasi-experiments often involve pre-existing groups, like comparing students in different schools that already use different teaching methods. You can still look for patterns and relationships, but you can't randomly assign students to those schools.
And with natural experiments, you're basically taking advantage of a naturally occurring event. Like if a town is hit by a tornado, you could study the psychological effects of that event, but you obviously can't control who experiences the tornado.
Exactly. So you're observing the effects of something that's already happened. You're not manipulating the independent variable in the same way as in a true experiment.
So it's like a different level of control, but you can still learn a lot from these types of studies.
You definitely can. They provide valuable insights into real-world phenomena that would be impossible or unethical to study in a lab setting.
Okay, so we've talked about experiments, but you mentioned that there's a whole world of non-experimental methods out there. What are some of the other tools in a researcher's toolbox?
Coolican is a big fan of observational methods, especially naturalistic observation, which is basically observing behavior in its natural environment without any manipulation, like being a fly on the wall, carefully watching and recording what you see.
That sounds really interesting. I can see how that would be valuable for understanding how people actually behave in the real world,
Yeah.
rather than in a contrived lab setting.
It's all about capturing behavior as it naturally occurs, but it also comes with challenges. You have to be very careful about minimizing bias and making sure your observations are accurate.
Right, because you don't want to misinterpret what you're seeing.
Exactly. Coolican emphasizes the importance of detailed and accurate recording, separating observation from interpretation. It's about sticking to the facts and avoiding assumptions.
So it's about being objective and minimizing the influence of your own biases.
And he also talks about different observer roles. You can be an active participant in the situation you're observing, a passive observer who's just watching from the sidelines, or something in between.
So like if you're studying how children interact on a playground, you could be another kid on the playground, or you could be an adult sitting on a bench observing from a distance.
Exactly. And each role comes with its own advantages and disadvantages. It's about choosing the best approach for the research question and the ethical considerations involved.
It sounds like observational methods are really powerful, but they require a lot of skill and careful planning.
They do, but they can provide incredibly rich and nuanced data that you might not be able to get from other methods.
Before we wrap up this part of our deep dive, I'm curious to hear more about those other non-experimental methods you mentioned. The surveys, interviews, and case studies. How do those fit into the research landscape?
Surveys are great for collecting data from a lot of people quickly. You can ask people about their attitudes, beliefs, behaviors, or experiences, all sorts of things.
But I imagine it's tricky to design survey questions that are clear and unbiased, and that actually measure what you want to measure.
It definitely takes practice and skill. You want to avoid leading questions or questions that are confusing or ambiguous.
Right, because the way you phrase a question can totally influence how people respond.
Exactly. And then you have interviews, which allow for a much deeper exploration of individuals' experiences and perspectives. You can ask open-ended questions, follow up on interesting responses, and really get a sense of someone's unique story.
It's like a conversation rather than a standardized set of questions.
Exactly. And that can be incredibly valuable, but it also means that interviews are typically more time-consuming and require a high level of skill to conduct effectively.
Makes sense. And what about case studies? What makes them unique?
Case studies provide a really in-depth look at a single person or a small group of people. They're often used to study rare phenomena or to gain insights into complex psychological processes that would be difficult to study in other ways.
So it's like a deep dive into a particular individual or situation.
Exactly, and while you can't generalize the findings from a case study to the larger population, they can still be incredibly valuable for generating hypotheses and for understanding the nuances of human experience.
So even though these methods might not involve manipulating variables in the same way as an experiment, they're still incredibly valuable for understanding the complexities of human behavior and experience.
Absolutely, and in some cases, they can even pave the way for future experimental research by providing valuable preliminary insights.
This is already giving me a much deeper appreciation for the variety and ingenuity of research methods in psychology. It's not just about one-size-fits-all experiments.
It's about having a diverse toolkit and knowing which tool to use for which job.
And speaking of tools, I'm really eager to learn more about how researchers ensure that their findings are reliable, valid, and truly meaningful.
That's a great segue because that's exactly what we'll be exploring in the next part of our deep dive.
I'm ready for more. Bring it on.
All right, so we've talked about all these different ways to design studies, but it's all for nothing if you don't have a good sample to work with, right?
That makes sense. I remember Coolican talking about the importance of representative sampling. So it's not just about grabbing any random group of people off the street.
Not at all. The people you study, your sample, needs to reflect the larger population you're interested in if you want your findings to be meaningful.
So if you're studying, say, the effects of stress on memory, but your sample only includes college students, can you really say your findings would apply to everyone?
Probably not. You'd want a more diverse sample that includes people of different ages, backgrounds, occupations, a real mix.
So how do researchers make sure their sample is actually representative of the population they're interested in? It seems like it'd be really hard to perfectly mirror the diversity of a whole population.
It's definitely a challenge, but there are a few different methods that Coolican explains. There's random sampling, which is considered the gold standard.
Random sampling, what's that?
It's basically like drawing names out of a hat. But on a much larger scale, every single person in the population has an equal chance of being selected for the study.
That sounds pretty fair, but I imagine it's hard to actually pull off in practice. What if you're studying a very specific population, like people with a rare disease? Randomly selecting from the entire population wouldn't be very efficient, would it?
You're right. In those cases, random sampling might not be the best approach. That's where stratified sampling comes in handy.
Stratified sampling. Okay, another new term for me.
It's basically dividing the population into subgroups based on important characteristics like age, gender, ethnicity, things like that, and then randomly sampling from within each subgroup.
So if you knew that a certain disease was more common in women, you would make sure that your sample included a higher proportion of women to reflect that.
Exactly. You're trying to create a miniature version of the population with all the important characteristics represented proportionally.
It sounds like sampling is a whole science in itself.
It really is. There's a lot of thought and careful planning that goes into selecting the right sample.
Okay, so we've talked about getting a good sample. Now, what about reliability? That's another one of those research terms that I feel like I should know, but I'm not sure I fully understand it.
Reliability is all about consistency. If you measure something multiple times, you should get similar results each time, assuming the thing you're measuring hasn't actually changed.
So, like, if I step on a scale twice in a row, I should get the same weight both times, unless I've suddenly gained or lost 5 pounds between weigh-ins.
That's a great analogy. And Coolican breaks down different types of reliability. There's test-retest reliability, which is basically consistency over time, like your scale example.
Okay, so if I take a personality test today, and then I take the same test again next week, my scores should be pretty similar, unless my personality has drastically changed in a week.
Exactly. And then there's inter-rater reliability, which is about consistency between different observers.
So if two researchers are watching the same video of a child playing, and they're both coding the child's behavior, they should come up with similar ratings if the coding system is reliable.
Exactly. If the ratings are all over the place, then it suggests that the coding system isn't very reliable, and it's hard to know if they're actually measuring the same thing.
So reliability is about making sure that your measurements are consistent, whether you're measuring over time, between different observers, or even within the same test.
It's all about reducing error and making sure that your data is accurate.
Right, because if your measurements aren't reliable, then your findings aren't going to be valid either.
That's a great point. Validity is all about making sure that you're actually measuring what you intend to measure and that your findings are meaningful.
I know Coolican talks about two main types of validity, internal and external. Can you remind me what those are all about?
Internal validity is about the study itself. Can you confidently say that the changes you observed were caused by your manipulation, by your independent variable, and not by something else?
So it's about making sure that those pesky confounding variables aren't messing up your results.
Exactly. It's about eliminating alternative explanations and isolating the true effect of your independent variable.
And Coolican uses that great example of the investigator lose procedure effect to illustrate a threat to internal validity, right?
He does. It's a classic example of how the researcher's own expectations can unintentionally influence the outcome of a study.
Can you refresh my memory on this study?
It was a study where researchers were led to believe that sensory deprivation either produced hallucinations or didn't produce hallucinations, and the researchers who believed it did produce hallucinations were much more likely to find evidence of hallucinations in their interviews with participants, even if the participants weren't actually hallucinating.
So it's like they were seeing what they wanted to see or what they expected to see, even though it wasn't really there.
Exactly. It shows how powerful our expectations can be and how they can bias our perceptions and interpretations.
So how do researchers protect against these kinds of biases?
One way is to use blind procedures where the researchers don't know which condition the participants are in. That way, their expectations can't influence their observations or interpretations.
So it's like a safeguard against our own subconscious biases.
Exactly. And it's a really important safeguard, especially when you're dealing with subjective measures like interviews or observations.
So internal validity is all about making sure the study itself is well designed and free from bias. What about external validity? That sounds like it has more to do with the big picture.
External validity is about generalizability. Can you take the findings from your study and apply them to other populations, settings, and even time periods?
So it's about whether your findings are relevant to the real world beyond the specific context of your study.
Exactly. And a key aspect of external validity is ecological validity, which is how well the study's findings generalize to real-life situations.
I remember that term, but I always struggle with it a bit. Isn't every study that takes place outside of a lab automatically ecologically valid?
Not necessarily. Just because the study is done in a so-called field setting doesn't mean it's automatically realistic. You have to consider whether the tasks, the procedures, the environment, even the way the participants interact, does all of that genuinely reflect the real-world context you're interested in?
Okay, I'm starting to see the nuance here. So it's not just about location. It's about creating a study that truly captures the essence of the real world.
And Coolican uses that example of the driving simulator to illustrate this point.
Oh, yeah, I remember that one. Remind me how that goes.
Imagine you're studying driver behavior using a driving simulator. Even if the simulator has incredibly realistic graphics, sounds, and even physical feedback, it still might not capture the full complexity of driving in the real world.
Right, because in a simulator, you know you're not really going to crash, so you might take more risks. And there are all those unpredictable things that happen in real-life driving, like bad weather or other drivers doing crazy things.
Exactly, all of those factors, the real-world consequences, the emotional stakes, the unpredictable nature of the environment, they all influence behavior in ways that a simulator, no matter how advanced, might not fully capture.
So ecological validity is a tricky thing to achieve.
It is. It's about degrees of realism and how well the study's context maps onto the real-world situation you're trying to understand.
And all of this, the sampling, the reliability, the validity, it's all part of the positivist approach to research, right?
Mhm.
The idea that we can use empirical methods to uncover objective truths about the world.
Exactly. And Coolican does a great job of explaining the positivist approach. But he also acknowledges that there are other approaches to research, like qualitative research.
Right, qualitative research. That seems very different from the quantitative research we've been talking about, all the numbers and statistics and whatnot.
It is different. Qualitative research is all about exploring the richness and complexity of human experience in a way that numbers often can't capture.
So instead of focusing on how many people do something or how often they do it, qualitative research is more about understanding the why and the how, the meaning behind the behavior.
Exactly. It's about exploring the subjective experiences of individuals, their thoughts, feelings, perceptions, their stories, their unique perspectives.
It sounds almost like an art form, a way of capturing the human experience in all its messy glory.
There's definitely an art to it. It requires a different set of skills than quantitative research, skills like listening, observing, interpreting, and synthesizing.
I'm thinking about those non-experimental methods we talked about earlier, like interviews and case studies. Would those be considered qualitative research methods?
Absolutely. They're classic examples of qualitative research. Think about it. If you really want to understand someone's experience of grief, for example, would a survey with multiple choice questions be the best way to do it?
Probably not. A survey might tell you how common certain symptoms of grief are, but it wouldn't capture the unique way each person experiences that loss.
Exactly. You wouldn't get the depth, the nuance, the emotional texture of their experience. That's where qualitative methods shine.
So it seems like both quantitative and qualitative approaches have their strengths and limitations.
Mhm.
Do researchers ever combine the two?
They do. It's becoming increasingly common to use a mixed methods approach, where researchers integrate both quantitative and qualitative data to get a more complete and nuanced understanding of a phenomenon.
So it's like using different lenses to view the same thing.
Exactly. Each lens provides a different perspective, and together they create a richer and more comprehensive picture.
This is all so fascinating. I'm starting to see research methods in a whole new light.
It's a rich and complex field, and we've only just scratched the surface, but hopefully this deep dive has given you a good foundation.
It definitely has, and I'm really looking forward to exploring the ethics of research in the next part of our deep dive.
That's a great topic to dive into next. It brings up some really important questions about the responsibilities of researchers and the well-being of participants.
I'm ready. Let's do it. Okay, so we've journeyed through the intricate world of research methods, from the scientific method to the nuances of study designs, from quantitative to qualitative approaches. It's clear that psychologists have a diverse toolkit at their disposal.
Oh, absolutely. A whole arsenal of methods to explore the human mind.
But as we shift our focus to ethics, it's crucial to remember that every research study, no matter how meticulously designed, comes with ethical considerations.
You're spot on. Ethical considerations should always be at the forefront of research.
And Coolican doesn't shy away from this. He really emphasizes the ethical responsibilities that researchers have, especially when working with human participants.
Absolutely. He's very clear about the importance of treating participants with respect and ensuring their well-being.
And one of the cornerstones of ethical research is informed consent, right?
Exactly. Informed consent is non-negotiable. Participants have the right to know what they're getting into before they agree to participate.
So they need to understand the purpose of the study, the procedures involved, any potential risks or benefits.
All of that, it's about transparency and giving participants the autonomy to make an informed decision.
It seems so obvious now, but I guess there was a time when researchers didn't always prioritize informed consent.
Unfortunately, yes, there are some infamous examples from the past. Studies where participants were subjected to harm or distress without fully understanding what they were signing up for.
Those studies were definitely a wake-up call for the research community. They really highlighted the need for clear ethical guidelines and oversight.
They did, and thankfully, research ethics has come a long way since then.
Now, Coolican also talks about deception, which seems a bit tricky. On the one hand, it seems like deception goes against the whole idea of informed consent. But on the other hand, I can see how sometimes it might be necessary to withhold certain information from participants to get accurate results.
It's a delicate balance, and there's a lot of debate about when deception is justified. Coolican's stance is that it should only be used as a last resort, when absolutely necessary to answer the research question, and when there's no other way to get the data.
So, like if you're studying how people react to surprise events, you might have to deceive them about the true nature of the study. Otherwise, their reactions wouldn't be genuine.
Exactly. But even when deception is used, it's crucial to debrief participants afterward.
Right. Debriefing is like the ethical follow-up. It's about explaining the true purpose of the study, any deceptions that were used, and answering any questions participants might have.
It's about being transparent, restoring trust, and making sure participants leave the study feeling okay about their involvement.
So it's not just about revealing the truth, it's also about acknowledging the participants' contribution to the research and treating them with respect.
Absolutely. And it's an important part of maintaining the integrity of the research process.
Now, this might be a bit of a sensitive topic, but Coolican also touches on the ethics of animal research. I know this is an issue that many people feel strongly about.
It is a complex issue. There are strong arguments on both sides. Some researchers argue that animal research is essential for advancing our understanding of biology and for developing treatments for diseases.
But of course, there are concerns about the welfare of the animals involved, especially when the research involves procedures that might cause them pain or distress.
Those concerns are completely valid, and Coolican emphasizes that researchers have a responsibility to minimize harm to animals, ensure their well-being, and use alternative methods whenever possible.
It's a tough balance to strike. How do researchers decide whether the potential benefits of an animal study outweigh the potential costs to the animals?
It's a question that's constantly being debated. There are strict regulations and ethical review boards that scrutinize animal research proposals to make sure they meet high standards for animal welfare, but it's a complex issue with no easy answers.
It sounds like there's a lot of nuance to this. It's not a simple black and white issue.
It's definitely not. It requires careful consideration, open discussion, and a willingness to grapple with difficult ethical dilemmas.
So, as we wrap up our deep dive into the fascinating world of research methods in psychology, I'm left with a few key takeaways. First, there's no one-size-fits-all approach to research. Psychologists have a diverse toolkit at their disposal, and the choice of method depends on the research question and the ethical considerations involved.
Absolutely. It's all about choosing the right tool for the job.
Second, even the best designed studies are susceptible to errors and biases. So critical thinking is essential. We can't just blindly accept the findings of any study. We have to look at the methods, the sample, the analysis, the whole package.
That's so important. Being a critical consumer of research is a crucial skill, not just for researchers, but for everyone.
And finally, ethics should always be at the forefront of research. From informed consent to debriefing, from minimizing harm to animals to being transparent about potential conflicts of interest, researchers have a responsibility to conduct their work in an ethical and responsible manner.
Ethical considerations should never be an afterthought. They should be woven into the fabric of the research process from start to finish.
Well said. And as we conclude this deep dive, we want to leave you with a final thought to ponder. In light of the ethical complexities we've discussed, do you think the potential benefits of a research study can ever outweigh the potential risks to participants, whether they're humans or animals? This is a question that researchers grapple with constantly, and there's no easy answer, but it's a conversation worth having, and we encourage you to continue exploring the world of research methods in psychology, keep asking questions, stay curious, and never stop learning.
Well said. It's been a pleasure diving deep with you. And to our listeners, keep those brains engaged and those critical thinking skills sharp.
Thanks for joining us on this deep dive. Until next time, stay curious.